Dear students, now we are going to derive the Kepler's first law of planetary motion. So here we will be, before that I would suggest you to go through the derivation for Kepler's second law of planetary motion, because some of the parts from that derivation will be used here. So it is a kind of continuation of that derivation. At first we will write down the statement of Kepler's first law of planetary motion. So it states that every planet moves in an elliptical orbit with the sun being at one of its foci. So we need to prove that when this condition of aerial velocity is constant, with this condition we can prove that the path of the planet is elliptical. We need to prove that. So this we need, if we prove that if aerial velocity is constant, the path of the planet is elliptical, or if path of the planet is elliptical, then aerial velocity is constant. So these are like both around same. So let us start with that. So how to do that? So first of all, we will be considering the statement that we have obtained in the last derivation, that is the aerial velocity h vector is constant, right? So actually h vector is nothing but half into r cross v. That's what we obtained last derivation. So from this we will simply do 2h vector r cross v. Be very careful about the about the vector statements. So this is our equation number 5, if you remember from the last derivation. Now we know that if you want to define velocity, it is always dr vector dt. Okay, so again r vector can always be written as r cap, where r is simply the magnitude and r cap is simply the unit vector. Now if I want to remove the bracket and do the derivation, so I will do the in differentiation by parts. So first of all I will consider r as constant, and it will be dr cap dt. Then r cap will be the constant, and it will be dr dt. So this is what we had for v vector. But we know that equation 5 implies, so this we will consider as equation 6 then, because equation 5 is this is equation 5. So we know that equation 6 implies 2h vector is equal to r cross v. Now we have v, r cross, so we will put this thing, okay. So it will be r dr cap dt plus r cap dr dt. So this is our 2h vector. So I will slowly, so in place of r vector I will write r cap cross r dr cap dt. So I would suggest everyone to take pen and paper and practice along with me. So now I will remove the bracket. So for that it will be r cap cross r dr cap dt plus r cap cross r cap dr dt. So here you can see that this is a constant part, this is a constant part, so I can take it out. So it will be simply r square. So it's a scalar part. Instead of telling constant, this is a scalar part and this is the scalar part. This is the vector part, this is the vector part. So what I'm doing, I'm taking the scalar part out. So it will be simply r cap cross dr cap dt plus, so here you can see that this is the scalar part and this is also the scalar part. So I will take them out. So it is r dr dt. Since this is a scalar part, we are not supposed to follow in order. So and then remaining r cap cross r cap. Now you can see here this thing r cap cross r cap means cross product of the same unit vector. So angle between them is 0. So sin theta is 0. So this part will become 0. So finally we have r square r cap dr cap dt plus 0. So we should also follow this. We should not leave it in the middle. So finally we have 2h vector is equal to r square r cap cross this. So h vector is equal to 1 by 2 r square r cap dr cap dt. So that's it we have right now. So let that be equation number 7 for us. Now if you remember our equation number 1 from the last derivation, we had f equal to minus capital G r cap, and from that we have mass into acceleration means dv by dt, g capital M small m bar square. So m gets cancelled. So we are simply left with dv dt is equal to minus g capital M by r square r cap. Okay. Now we will make a transition again here. Now taking cross product with, so let it be our equation number 8, with h vector on both sides of 8 we have. So what I will do, dv dt cross h vector, fine, and then this is constant, this is a scalar, this is also a scalar. So then I have r cap, and then we have h vector. Now interesting thing is capital G small m r square, these are all scalar. R cap is a vector. Now we have h vector from equation 7. So I will put the value of h vector from equation 7. It is half r square r cap cross dr cap dt. So it is again half r square r cap cross dr cap dt. Again you can see that this is a scalar part. This is the scalar part. So I will take everything on the one side. So half gm by r square. So again it will come as half r square. So then it remains r cap cross r cap dr cap dt. So here you can say r square gets cancelled, and we are simply left with minus gm by 2 and then r cap cross r cap so this is what we have right now. Now as I think we have already discussed this in classroom. So is it looking like a vector triple product? Okay, so if I go to that, so we will be doing a little bit of graph work. So if it is A cross B cross C, if it is a vector triple product, how to do that? First of all, we will keep B outside and it will be simply A dot C, and then it will be C outside and it will be simply A dot B. So this formula we are going to apply. So here this is our A vector, this is our B vector, this is our C vector. So we need to be very patient to use this formula here. So be very careful and be slow and correct. So gm by 2 will be outside. So you draw the square bracket and start solving it. So how to do that? You cannot skip the points. So first of all, I will keep B outside. So it will be R vector. Inside that dot A dot C. Similarly, C outside. Okay. Then we have A dot B. I hope you are doing it along with me. Now here you can see that. Let me again. This is the unit vector along the radius vector, and this is a rate of change of unit vector. Unit vector with time. So this is a kind of radius vector and this is a velocity vector. If you remember in my one of the class, I told you that if this is r, this will be your dr dt. So r is always perpendicular to dr dt. So r cap will always be perpendicular to dr cap by dt. So this thing we have already discussed in class. So according to that, in this particular thing, so according to this here, we have a dot product and the angle between them is 90 degree. So cos 90 is nothing but 0. So this part will simply become equal to 0. So what we are left with? So we will have minus gm by 2, and then we have minus dr cap dt, and again if you talk about r cap dot r cap, so it is r cap modulus of r cap and again cos 0 degree. So this is 1, this is also 1, this is also 1. Finally the whole thing is equal to 1. So this part becomes 1. So it is nothing but 1. So simply we have so finally we can write dv dt h vector minus minus plus gm by 2 dr cap dt. Now I will make another transition. So I will in place of, so let me write it as a rough form. So in place of dv dt cross h, I can put d dt of v cross h. I have followed the same thing in the last derivation also. So my suggestion is to, I will leave it for you to disprove it. So in exam we are not supposed to show the steps, but I would suggest all of you to do it as your homework. So how we can write in place of dv dt cross h vector to be equal to d dt of v cross h vector. How this transition is possible? So you will do it as at home as your homework. So I will be using it directly. So it is d dt v cross h is equal to gm by 2 dr cap dt so if I write it as v cross h gm by 2, I can write it simply as dr cap dt. So integrating both sides we have, so integration v cross h, so gm by 2 integration dr cap. So since this is an integration without limit, we must write a constant of integration, say c. Okay, so where and all of them are vectors. This is also vector, this is also vector, this must also be vector. So where c vector is a constant of integration which can be determined by boundary conditions. Okay, so therefore, so you know that let me again do the rough sketch. Integration dx is x, right? So integration or integration v cross h will be equal to v cross h. Okay, if you can draw the parallels between these two things. Okay, so what I will be writing, so in place of this I have v cross h, then gm by 2, and integration dx is x, so integration r cap is r cap, so I have r cap plus c vector. Okay, this is rough work. Now taking the dot product with r vector on both sides. So let it be our equation number. Let me check what was the last equation number we used. 8. So this will be our equation number. Say 9. On both sides of 9 we have, so it is r vector dot v cross h, and then we have gm by 2, all scalar things. So r vector dot r cap plus r vector dot c vector. Okay, so if you know one thing, this is it. In this case, again let me do the rough thing. So if it is like r dot v cross h, okay, so we can just change their position in this direction. So if I put h here, so it will, r will come inside. Okay, again if I put, so h is gone there and r will go this side. Similarly, if I want to put v here, so it will be v vector dot h vector cross r. Alright, so we can write like this. We can change the position in the anti-clockwise direction. So in place of r dot v cross h, we can write h dot r cross v. This is one of the convenient ways to write it. Again, this is gm by 2, fine. So this is again a dot product. So dot product means modulus of r vector means r, modulus of r cap vector is 1, and cos theta, obviously you are asked the angle between r vector and r cap will be cos 0 degree, and this is r, modulus of r, modulus of c, and then we have cos theta. Fine. So we have further simplified like this. So it is gm by 2, and it will be simply r because cos theta is equal to 1, and then we have rc cos theta. Let me remove this part. Again, if you remember, r cross v is nothing but 2h vector. If we can go back, let us see where is it. Yes, see, r cross v is equal to 2h vector. So this is from equation number 6. It is always advised to write down the equation from where you have made the modification. So it is gm by 2r and rc cos theta. So it is from 6. So finally 2 is outside, h dot h gm by 2r and then you have RC cos theta. Then it is 2h dot h means h square, and it is gm by 2r plus rc cos theta. Now I will divide both sides by 2h square. So it will be 1. So it will be gm small r by 2 into 2h square plus rc cos theta by 2h square. Okay. Then I will divide both sides by r square. So I will put r square here. Sorry, not r. I will divide both sides by r. So gm small r 4h square r rc cos theta by 2h square r. R and R gets cancelled. R and R gets cancelled. So finally remains gm by 4h square. Then we have c, then cos theta by 2h square. And finally, I will multiply both sides by 4h square by gm into r. 4h square by gm, gm 4h square, 4h square by gm, c cos theta by 2h square. So this and this gets cancelled, and this 2 gets cancelled, h square gets cancelled. So finally we have 1 plus 2c cos theta by gm. Okay. So this can further be modified as L by R plus 1 plus E cos theta. So this is our equation number 10, and this is our equation number 11. So this is actually a equation. This represents a conic section mathematically. With L as the semi-latus rectum and E as the eccentricity. So I would suggest all of you to go through your 12th standard books to understand about latus rectum and eccentricity. So here, if theta is less than 1, equation 11 represents an ellipse with the sun at one of its foci. So this thing is nothing but Kepler's first law of planetary motion. That's